Hello friends, welcome to our channel Google Galaxy. Today we are going to discuss about the structural representation of organic chemistry. Structural representation of organic chemistry. There are a number of ways to represent the organic chemistry compounds while drawing the structure. Few of them are: there are a number of ways to represent the structures of organic chemistry, and these are: first one is dot structure. Second one is dash structure. Third one is condensed structure. Next one is condensed structure. And the fourth one is bond line structure. Since the organic chemistry is made up of millions of compounds, we can prepare the millions of compounds with the help of organic chemistry reactions. And those prepared compounds, those reactants, those products are represented by these four ways. It may be represented as a dot structure, it may be as a dash structure, it may be as condensed structure, it may be as bond line structure. So there are several ways to represent the structures of organic compound. Let's talk about step by step. When we talk about the dot structure, this is well known because you already studied in the junior classes, but still we will discuss a little bit. Let's talk about the dot structure. When we talk about the dot structure, since we know that, let's talk about the simple example, then we will move towards the complex one. We are having the CH4. Carbon is having the atomic number 6 and its outermost shell is having 4 electrons. And the hydrogen is having the atomic number 1. So it is having 1 electron, it's its outermost shell called as valence electron. This carbon having the 4 electron in its outermost shell, and the hydrogen, how many hydrogens are present over here? 4. So that is why I'll write 4 hydrogen. Okay. All of these elements, the whole compound is made. The science, the organic chemistry tells that the carbon, the bond between the hydrogen, the combination of hydrogen and carbon is possible only when they complete their octet. Octet means they must have outermost shell fully filled. If they are having incomplete outermost shell, it means they are not stable. So therefore they will never make a compound. If I talk in the terms of Bohr theory, if I talk about the Bohr theory, when we talk about the carbon over here, there is 2, 4, and the hydrogen is having 1. How many electrons are required to complete its octet? K is having the capacity of 2. 1 electron is required for the hydrogen, and the 4 electrons are required to complete their octet to 8. How many electrons are required for the hydrogen to fill its octets? There is single only. Why so? Because K is having 1 electron extra. The hydrogen requires 1 electron extra to complete its outermost shell. When we talk about the carbon, it needs the 8. That is octet for 8. So therefore what they made a covalent bond by sharing their electrons like this. Now I'll say the hydrogen becomes stable, and what about the carbon? It needs the total 8 electrons. So sharing the carbon of hydrogen, they made a compound 1 2 3 4 5 6 7 8. So after sharing these electrons, the carbon becomes stable. Hence this formula, this whole structure representation is called dot structure. If I just write the dash structure of CH4, it would be like this. The dash structure, this is called dash structure. On the both ends of the dash structure, it represents the one electron is shared by each of the element. Similarly from this side, from each side. Clear? This structure is called dash, this structure is called this is dot. As we discussed the dot structure, we need to complete an octet. Most of the times, about 80% in organic chemistry, we need to draw the dash structure. So dot structure is not that much important, as we more prefer the dash structure over here. Let's talk about the more examples of dash structure. Then we will discuss the condense. After that we will discuss the bond structure. So need not to worry about the dot structure because it's not that much important. We will talk about the dash structure. Let's talk about the ethane. We are having number of examples. We are having ethene. We are having methanol. You have to just understand how these structures are drawn. You need not to worry about how they named as methanol. Once you understand the dash structure, after that, after few steps, we will discuss about in the next video we will discuss about the how to write the IUPAC name methanol. There are a number of ways. Okay. When we talk about the ethane, this type of structure we called it as dash structure. Similarly for the ethene, double bond is present over here. Ethene. This is a dash structure. When we talk about the methanol, we are having OH group over here. It's all up to you whether it's not a necessary thing that you have to write the lone pair over here. Lone pair is when a group of 2 electrons, it is called lone pair. It's not a necessary thing to write a lone pair over here. It's all up to you whether you write or not. The teacher will not made it incorrect. This is whole about the dash structure. When we talk about the condensed structure, this one is more important than the dash structure. Condensed structure. Just take a look carefully. Let's take a look carefully. When we talk about the condensed structure, if I just write it as ethane as CH3, this is condensed structure. CH3, this is condensed structure. If I just write ethene would be written as CH2. Don't get confused. We will write in this way also. CH2. These both are having the same meaning. Need not to be confused. When we talk about the methanol, we will write it as CH3OH. This is what? This is condensed form. This is all 3 condensed forms. If I just write the difficult one, I hope you will understand. We will write condensed form. After that we will change it into the dash form. Let's talk about the condensed form. if we are an example given to us, that is CH3 CH2 CO. Let's take a look. This and this compound is given to us. How we can write in the dash form? We will write it as CH3. After that CH2 H2. After that carbon is present over here along with the double bond of oxygen. Why we write double bond over here? We need to complete the octet. How we can complete the octet? 1 2 3 4 5 6 7 8. Similarly for this carbon, 1 2 3 4 5 6 7 8. If the octet is complete, we will say our structure is correct. If any case the octet is not completed, there are four. If there is no 4 dash present over here, first dash, second dash, third dash, 4 dash. If 4 dash are not present around the single carbon atom, we will say the structure is incomplete or incorrect. Let's talk about this carbon. We are having the hydrogen present over here. This is dash structure of this condensed form. Clear? If someone, let's talk about the another example. If dash is given to us, we need to convert it into the condense. How we can write? For example, we are having this equation given over here. Nitrogen with the triple bond of carbon. Alcohol group is present over here. This is dash. We need to convert into condense. How we can convert it into condense? We will write it as dot can confused. Take a look. How many CN is present over here? 2 times. So we will write it as carbon, nitrogen, both are combined 2 times. This is condensed form. If I just write it as what is left over here, we are having the CH, C, OH. So we will say OH is present over here with the carbon. How many carbons are present over here? 2 carbons. So we will write it as, this is the condensed form. Let's talk about the another example of condensed formula. If something is given to you like this in the question, you can condense it into the form of how many CH3 is present over here. You can write it 2 times, or you can write single time 1 2 3 4 5. 5 times CH2 is given to you, so you can write it as 5 times along with the CH3. Or you can condense into the condense into another form, that is CH3 2 times with CH5, CH2 5 times. This is the another form of condensed form. This is another condensed form. Clear? The bond line structure plays an important role in your organic chemistry. The few things you need to learn before writing the bond line structure, that the first one is not to write carbon and hydrogen. Not to write carbon and hydrogen. The second one is follow zigzag path. Zigzag, we will write it fashion or path. Third one is we need to write oxygen. You need to write the other elements other than carbon and hydrogen. You need to write oxygen, nitrogen if present within the bond line structure. Need not to write the carbon and the hydrogen. Right? The fourth one is you need to join the functional group at the terminal. Attach alkyl or functional group at terminal. After learning these all four steps, you are able to write the bond and structure. If someone write you is in the form of this, don't get confused. It means at the each end carbon is present over here. So how many carbons are present here? 1, 2, 3, 4. Along with this single line, we called it as butane. If someone write like this, each carbon is present automatically over here. I have written carbon over here for your convenience. You need not to write the carbon over here, over the terminals and on the bond line structure. But if someone write like this, it means that single bond, double bond. So we will write it as butene. If you write like this, it means triple bond. Single bond, double bond, triple bond. We will write it as butene. How many carbons are present here? 1, 2, 3, 4. It means automatically hydrogens are present over here. You need not to count. You need not to write. We will write it not to write carbon and hydrogen. We hadn't write the carbon over here and the hydrogen over it. It means automatically carbon and the hydrogens are present over here. Clear? This is there are number of examples. Okay? These rules are same for the all structures. Let's talk about the another. If someone write is in the form of, if someone told you to write how many, what does it mean? It means first, second, third, fourth, fifth, six for hexane. If someone like this, it means methyl group is attached over. It means automatically means it is having the CH3 group. CH3 means methyl. So we will write as 1, 2, 3, 4, 5, 6. 6 carbon is present over here. 6 for hex. Single bond for ane. And the methyl group is attached over here. So we will write it as 2-methyl hexane. It means 1, 2, 3, 4. 4 for butane. 1, 2. 2-methyl butane. If someone places double bond between the two carbons, you will write butene. If triple bond is given to you, you will write the butene. It's not a necessity to attach a methyl group particular in this way. You can also write like this. This is also a methyl group. This is on the second carbon 1, 2, 3. On the third carbon 2 methyl groups are attached. So we will write as first carbon, second carbon. Branch chain should be nearest number. So that is why I'll write it as 2, 2 dimethyl 1, 2, 3, 4 butane. Don't get confused. Why I'll write 2, 2? Because nearest number is given to the branched. This is whole about the. This is what? This is bond line structure. If something is given to you is in the form of let's write difficult example some. Okay. Bromine is present over here. Bromine is present over here. What does it mean? It means that we will write the 1, 2, 3, 4. 4 carbons are attached to this bromine. We can also write like this. Don't get confused, both are having the same meaning. To write it in the form of condensed form, we will write condensed form. Condensed form, it should be in this form. This is condensed form. This is bond line structure. I think bond line structure is clear to you. If I just write this is the bond line structure, you need to expand. How would you expand? We will expand is in this form. Carbon is present between the each dash present over here. Each need to complete their octet. So how many dash are present over here? It must be 4. 1, 2, 3, 4. 4 hydrogens, 4 hydrogen. Similarly, 2 here, 2 here, 2 here. When we talk about this carbon is present over here. 1, 2, 3, 4. So octet is completed. When we talk about this carbon, we need to just complete the octet. So I'll write CH3 over here. Don't get confused. Why I write CH3 over here? Because we need to complete the octet for each of the carbon atom. If the octet is not completed, it means you are drawing the wrong structure. This is all about the bond line structure. So keep practicing the NCERT exercise. After completing the exercise, you will able to do any kind of numerical, whether it is based on the bond line structure, condensed form structure, dot structure. Hope for the best. If you like this video, don't forget to subscribe and share with the others. Thank you very much.